to my channel. My name is Anayati and today I'm going to talk about intelligent driving and drive-by-wire technology. To operate a car, we need a few things or factors to work hand in hand to have a fairly good and stable driving. These factors are a certified driver who has the license to operate that car, enough power that is provided by an engine and of course is ready to be used, and this power should be transferred to the tires by a powertrain, and to start the car, start to moving, speed regulation, maneuvering, and also stop the car and turn it off, we need driver's commands and some means to satisfy these commands. And these last two factors are the subject of this video. In an old and conventional car, driver's commands require mechanical means for realization. Even for starting, they had to use a lever to turn the crankshaft, but with electrical developments, it got possible for drivers to use an ignition switch and an analog signal from inside of the car to start that. And today, with developments in electricals, electronics, and computers, engineers and designers are thinking about new approach for controlling and commanding the cars. And this new approach is known as drive-by-wire. By-wire technology has its root in aircrafts, and in this type of vehicles, it is known as fly-by-wire technology. But development of this design in aircrafts led to autopilot systems that in fairly modern aircrafts, computers control the flight even better than the pilots without exhaustion. And Boeing 777 and A320 Airbus are the first commercial airliners that utilize fully computerized flight control systems. At the start, there was some efforts for adopting aircraft's anti-skid systems on cars, but first deployment of by-wire technology in automobile industry is attributed to Chevrolet Corvette in 1980 using throttle by-wire system to control the engine respiration electronically. But process of turning a conventional controlling system into by-wire controlling system requires some provisions. First of all, you need to have at least one computer. Also, you need to have a slave that can be an actuator, a motor, or a solenoid, or any other component that can turn electrical power into movement and function. And at the output, you need to have at least one sensor that sends the feedback to the computer. In this diagram, you can see a simple sketch of a by-wire controlling system and its controlling logics. And as you can see, driver decision is delivered to the computer by an analog or digital signal. Anyway, the computer has the provisions to convert the signal into digital type in its receiver. Computer decides an output and sends that to a slave. Function of the slave is sensed by the sensor, and feedback is sent to the computer by an analog or digital signal. In the case of throttle by wire system, driver presses the accelerator pedal. One or two sensors on the pedal sense the change in pedal travel and send it to the computer, and computer, based on last location of throttle, adjusts the throttle, and one or two sensors on the throttle body send the valve position to the computer. In this case, if the adjustment and feedback correspond to each other and engine works fine, the process is complete and driver is satisfied. But in the case that sensors do not confirm the desired slave movement, or engine response that is evaluated by oxygen sensor is not desirable, a trouble code would record in computer memory or check engine light comes on. But using and deployment of these by-wire controlling systems requires taking a few steps. You need to replace mechanical commanding with electrical commanding, and human sensing with electrical sensing, and also mechanical means and linkage with wiring harnesses. And this deployment has a direct effect on price and level of the cars and increases complexity, because engineers should assign function of each system to a module or computer and connect these modules into a network to decrease wiring and increase speed and reliability. So going more toward intelligent controlling and increasing comfort of occupants results in increase of cost of production and of course price of the cars. In this chart, you can see direct effect of level of intelligence and number of modules on car price and level. And as you can see, older and cheap cars have no to low level of intelligence and have 0 to a few number of modules, and normal and medium cars have medium level of intelligence and have around and less than 30 modules, and luxury and expensive cars have high level of intelligence and have more than 30 modules. So owning a car with high level of intelligence and comfort leads to paying more money for initial investment and also repairs, because these by-wire controlling systems require some special diagnostic tools and equipment to communicate with modules, and since the faults are mainly related to solid-state electronics, repairing them requires module replacement, and sometimes buying new sensors or actuators that usually cost of programming them into their job is equal to replacing that equivalent system on an old and conventional car. And other than being very expensive and requiring some special diagnostic tools and equipments, these by-wire controlling systems have some other drawbacks too. Even if you have those special tools and equipment, only a well-trained technician can use them and interpret the results and data, and usually the owner do not have any idea of the faults and solutions. And also, more electrical components leads to more electrical energy consumption. So when you go to buy a new battery for your car, you need to pay more for a better quality battery with higher electrical capacity. And also, in parallel to increasing complexity of by-wire systems, always there are some security holes that a well-educated hacker can use them to intrude through the car and steal that, and even use that in an illegal activity and action. And also, in a car with high level of intelligence and by-wire systems, faults and malfunctions can be very dangerous, because many main decisions are made by computers, so their misdirection can be fatal or result in property damage. But on the other hand, these by-wire systems have some benefits that encourage manufacturers to deploy them. The most important one is that these systems, relying on their digitized and networked way of communication, are faster and have a more accurate operation in comparison to old and conventional systems. And also, eliminating mechanical means and linkage and using mechatronics and computers saves a lot of weight and space on the cars. And also, you do not need to do those boring regular inspections and lubrications and replacement of bushings and bearings that are prescribed for those old school type vehicles. And also, it is possible for manufacturers and some aftermarket companies to give out programs to upgrade the computers and maybe resolve the faults and malfunctions. But what is the prospect of future? I think development of electronics, cars and aircrafts ends up in emergence of intelligent transformers in the future. But for coming years and decades, driverless and fully autonomous cars are a certainty. But before and on the way to these fully autonomous cars, I think automotive industry would experience some technologies. One of these technologies would be bodiless commanding. In an intuitive interaction package that can be used on cars like biometric vehicle security systems that use retinal eye scanners and fingerprints, and also active health monitoring systems that can use some parameters to control and monitor the health condition of occupants. Bodiless commanding would be very desirable and likely to be used on cars. In this technology, the driver uses his or her voice or brain signals to command and control the car, and vehicle has some interfaces to receive and interpret these signals and deploy them. Another significant progress that can be used on cars would be augmented reality and intelligent road interaction. In this technology, the car uses advanced GPS information and active windshields and cameras to alert and guide the driver and even passengers. Up to now, there have been some experiences by some companies like BMW and Mercedes-Benz and some deep tech companies out there, but maturing this technology requires some infrastructures and maybe demand stays, fundings and management. But combined with virtual reality, these technologies can be marked as a revolution in car industry and even maybe require driver certification to use them. And also by development of satellites and networks, humankind can experience another technology that is known as vehicle-to-vehicle or V2V communication. Look at the bees and ants and how they use their antenna to communicate with each other. They do not have any impact, and if one of them knows something, many of them know that in a few seconds later. Inspired by this way of communication, humans can avoid a majority of vehicle-oriented crashes. And on the way to fully autonomous cars, automotive industry would experience another technology that is called remote diagnosing. In this technology, intelligent cars know their health condition, and if any fault happened to them, they go into fault tolerance or fault correction modes and even download the updates remotely and automatically. Another aspect of this technology is that if the faults require shop visit, vehicle can book for that visit automatically, and after that inform the owner for confirmation. And since the car knows the shop address, it can manage and guide the driver to get there. And finally, fully autonomous cars. However, these technologies and cars are very interesting for everybody, but coming them into the market and moving in the cities and highways have some restrictions and limitations. Restrictions are related to laws and regulations, and limitations are related to technology. Based on today's technology and potentials, on a modern car we need at least 80 modules to work in a few interconnected high-speed networks to have a fairly fully autonomous car. Here I can complete this chart, and here it is very expensive. Autonomous car. And they require more than 80 modules. And I think with development of technologies at the time of these fully autonomous cars, the number of main modules are going to decrease significantly, and the vehicle controlling and module configuration is going to go toward live creatures' anatomy. And if you have powerful modules that can process a lot of information and make a lot of exact decisions, you can assign a lot of controls to these modules. And eventually, if you have a very strong module that can process and control everything, you can have a central module that can work as the brain of that creature. And if you create something that can sense and understand environment and recognize your voice, your tone, your face, and even your feelings, and also interact with you and environment, you have created a semi-live creature. Here, I don't want to go further in this subject, because from here, science, philosophy, and religion are going to clash to each other. But for now, I think the most important thing is that engineers and designers concentrate on providing proper controlling logics and making strong and high-speed microprocessors to prepare the base for future developments. I hope that this video was useful and informative for you and worth the precious time that you spent for watching that. Please subscribe to my channel if you like, and press the bell icon to be notified if I have a new video on my channel. Bye.